they're some of the most dynamic, dazzling, jaw-dropping displays in nature.
It's these rocket ships and explosions of sparks and spewing of what looks like blue smoke. And these long chains look like Japanese lanterns extending off into the distance as far as you can see. It's magic.
Some flash, some sparkle. Others simply glow. But most we're only beginning to discover.
Suddenly we recognize it, and now we find it everywhere under there.
Hidden in the deepest, darkest, most remote stretches of our planet, these luminous critters can be timid performers. But the closer we look, the more we realize the light they create is pervasive.
If it wasn't important to the organisms, you wouldn't see it all over the Tree of Life.
Now, scientists are thrusting these cryptic creatures and their fantastical displays into the limelight. Some are even attempting to harness this light, co-opting millions of years of evolution for the betterment of our own dim species.
We have to go down to the ocean to find these animals that give off light so we can then understand ourselves. To me, it's a beautiful connection.
We're shedding light on the creatures of light. Right now, on this NOVA National Geographic Special.
Major funding for NOVA is provided by the following. The David H. Koch Fund for Science, supporting NOVA and promoting public understanding of science. And the Corporation for Public Broadcasting, and by PBS viewers like you. Thank you.
It's one of life's essential ingredients. We soak up its energy, set our clocks by it, need it to see. Light is so precious to us humans, we've coaxed it into lasting all night long. But imagine a world without it. While we're cursing the darkness, countless thousands of other species have evolved a much brighter response. Without burning an ounce of fossil fuel. It's called bioluminescence. Living light. And from glowworms and fireflies to plankton and jellyfish, it's been lighting up the dark for hundreds of millions of years.
If you look across the Tree of Life, essentially, bioluminescence is splattered all over it.
It's just everywhere you look. How to survive in the dark? Make light.
On land, where it's dark only at night, just a fraction of creatures evolved the gift of glow. But descend into the deepest depths of the oceans, where the bulk of Earth's creatures reside, and you find a very different story. Down here, as many as 90% of life forms shine.
I'm going to come off the wall and head out into open water.
Surface, this is Nadir. Our present depth is approaching 100 meters. Life support, okay.
That's why a team of scientists from New York's American Museum of Natural History is here, plying the dark waters of the South Pacific Ocean in search of new luminescent creatures.
I'm going to start motoring away here.
They've journeyed to the other side of the world, to the pristine and remote waters of the Solomon Islands, to unravel how and why light-producing animals evolved, and perhaps put their living light to work for us. David Gruber is a marine biologist.
After about 100 meters in the ocean, you will get into this twilight zone. About 1% of the light makes it down. So as we start getting deeper, you'll start seeing almost everybody down here. Every fish that we see has this ability to blink or flash or communicate, producing its own light.
The problem is, common as bioluminescence may be down here, it's challenging to study, even with a submersible. The water is too dark. The distances are too great. And the light the animals give off is too unpredictable. It's a tough environment for marine biologists to work in. But a neuroscientist like Vincent Peerybone feels especially out of his depth.
I'm a scientist that spends most of his time in a laboratory, so it's very scary, to be completely honest with you. You gotta keep your head and your wits about you and try to focus on what the job is and not really think about the fact that there's, you know, a few tons of water on top of us at the moment, so. But we're here in the name of science, so we press on.
Ooh, that's siphonophore.
One goal for this trip is to develop a better low-light camera. Deep-sea bioluminescence has only been filmed in the wild a handful of times. Most of what we know comes from observing animals in carefully lit tanks on the surface. Whether it's the infamous anglerfish with its luminous lure, or the light-packed viperfish, one of the deep's most ferocious predators, scientists typically collect them in small trawl nets, like these.
Bob, you're gonna turn around the net, right? Yeah. All right, thanks.
They then examine their unique light-producing organs to infer how they work. That's what biologist John Sparks is trying to do with this viperfish. They may be fierce, but even the big ones are actually pretty small.
This is a monster for these things. They're a bunch of different species. They're hard to tell apart. I mean, I've actually never seen one that big. We still know so little. That's what's kind of frustrating. You got to get the organisms up alive, which is tough. You got to be able to image enough different species to make it meaningful. But in terms of us doing anything scientific with it, it's very tough because we've got so little data.
What scientists want to understand is how luminescent features became so pervasive in the deep ocean, and why, in a world full of predators, would animals invest so much energy into lighting up and standing out in the first place. They are questions marine biologist Edie Widder has been grappling with for decades. An expert on living light, she was among the first to study it underwater.
I wish I could describe what it's like to be down there because I would like people to be able to appreciate it the way I have. It's these rocket ships and explosions of sparks and spewing of what looks like blue smoke and these long chains of siphonophores that are like chains of jellyfish that look like Japanese lanterns extending off into the distance as far as you can see. It's magic.
Edie devised her own methods to trigger these underwater light shows. She mounted a large screen on the front of her submersible. When creatures bump into it, they light up, and her low-light cameras record them in the act. Over the years, the aptly named SplatCam has helped bring to light some of the most bizarre creatures in the deep. Everything from jellyfish to sea cucumbers.
The open ocean is the biggest living space on our planet, by far. And it's a very unusual environment. There's no trees or bushes to hide behind. But animals have to play all the same games of hide and seek that animals do on land. And that's where bioluminescence comes in.
In this deep, dark abyss, light, it seems, is vital. And creatures have evolved to wield it in many different ways, for many different reasons. Tiny organisms called dinoflagellates, for example, alight in unison whenever the water around them is disturbed, taking the shape of whatever swims through them. It's a treat for the lucky few who get to bask in their soft glow. But for predators of these microbes, like shrimp, it's more like tripping a motion sensor. Every time they make a move, the lights come on and give away their location. Predator becomes prey to a host of other creatures, like cuttlefish. But some shrimp are armed with their own light-filled defenses. When threatened, certain species shoot bright flashes of light to stun and confuse their enemies.
There's a lot of animals that actually can release their luminescence that way. So you can have something like a shrimp that will spew luminescence out of its mouth like a fire-breathing dragon and temporarily blind its predator while it pulses away into the darkness.
Rather than blinding their predators, a huge variety of fish, from squid to sharks, use light to hide from them. It's called counter-illumination, and it may seem counterintuitive, but consider how a fish swimming near the surface appears to a predator in the depths below. As sunlight or moonlight beams down on them, their silhouettes are plain as day.
And so an enormous number of animals in the ocean produce bioluminescence from their bellies that exactly matches the intensity and the color of the sunlight coming down through seawater.
When the lights come on, the animals vanish.
It's an amazing cloaking device. They just disappear, utterly disappear.
Others, like ostracods, tiny shrimp-like critters, use light a bit more extravagantly. They ooze light to stand out and impress the opposite sex.
Ostracods, which is about the size of sesame seeds, produce a crazy amount of light for such a little organism. And they'll squirt out one little dot, and then they swim a little further and they squirt out another dot and another dot. And the spacing of the dots is species specific. And so the female can recognize the male that she can mate with. So it's almost like skywriting, but it's light writing. It's beautiful.
But mates aren't the only creatures light attracts. Many fish use light to lure food in, as does the most notorious bioluminescent creature of all.
What is it?
It's so pretty.
Remember that ugly angler in Finding Nemo?
Good feelings gone.
That lure is actually meant to attract another fish or another little shrimp that comes to gobble it up and then finds itself engulfed in this living mousetrap of needle-sharp teeth.
Lures, motion sensors, cloaking devices. All together, bioluminescence lights up the deep like an aquatic Times Square.
Bioluminescence was a tool that was laying out there. Somebody was like, I could use it for this, and somebody's like, well, I could use it for that.
They use it to find food. They use it to avoid being eaten. They use it for mating, and they use it to communicate with each other, just like all these signals are trying to communicate with us. Things that are very important to not only the individual, but the species as well.
Despite all the risks, light is a shining example of Darwin's theory of evolution. From bacteria to jellies to fish, it helps organisms survive. But the question remains, how did the initial spark for this light arise? To find out, scientists have turned to a different set of bioluminescent creatures, ones that are a bit more familiar and easier to study. Land critters have evolved their own special ways of using light. Take the glowworm, for example. Like anglerfish of the deep, thousands of these fly larvae light up the roofs of these caves in New Zealand like the night sky to lure in a meal. The starry ceiling fools prey like flies and moths, which are attracted to the light. As they fly upwards, they get trapped by the glowworm's sticky, thread-like snares. Rather than luring prey in, other bioluminescent creatures, like this millipede in the Sierra Nevadas, uses light as high-voltage signs to keep predators out. The bugs are laced with cyanide. Their nuclear glow alerts potential predators to leave them alone. And then there are probably the most familiar displays of all. The brilliant flashes of fireflies are some of the most sophisticated mating strategies ever evolved. The ultimate in romance languages. By triggering a chemical reaction in their abdomens, male fireflies can turn themselves on or off on cue. And if they do it just right, they'll turn on female fireflies too. University of Florida biologist Mark Branham has devoted the last 15 years to deciphering this elaborate language of love.
It's like breaking the code.
A secret code that has two parts.
If you actually measure these flash patterns very, very carefully, there are some features that are always standardized, and we think those are the parts of the signal which say, I'm a member of the following species. One
of the 2,000 different species of firefly. which are actually not flies at all. They're beetles.
But there's also parts of the signal that have a lot of variation.